Okay, turn past all this garbage here on the front page, and we're going to solve some story problems learning using a different type of function. Okay. First problem says, the owner of an original copy of a comic book sold it at an auction in the year 2005. The owner bought the book in the year 1980 for $55. The value of the comic book increased at a rate of 3% each year. How much should the comic book be sold for? So we're going to go with the old reliable here. But we're not going to be able to make the line, and you'll see why. So dollars and years. X, Y. Okay, so per. Dollars per year. Here's the problem. There isn't a dollars per year. It's a percent per year. Okay? So, cross out the dollar sign and put percent. Now, here's what you're going to do with your percent. You're going to write plus 3% because it increased. If it was not an increase, it would be minus. Then here's what I need to do. This will not be a linear one then. Okay? If I don't have the dollars per year, a dollar amount that I can just add over and over, okay, it's not going to be a linear function. Okay? We're still going to use a table, but it's not going to be a linear function. Okay? What that means is put exp for exponent function. Okay, so, but you need to do something with your 3%. You need to take 100% and add 3%. And that would be 103%. Now, below that plus 3%, put 1.03. Okay, that's your exponential growth factor. It's growth because it's more than 1. So when I set up my table, I'm going to do the same thing I did with the linears earlier this year. I'll go 0, 1, 2 and make a line. So the money starts at $55. But I don't add, I multiply. That's why it's called an exponential function. So times 1.03. So 55 times 1.03 finds what it is after the first year, $56.65. If it's money, put 2 decimal places. Then I times 1.03 again. So 56.65 times 1.03. 58.34, but the 9 after it would be 58.35. If it's money, put 2 decimal places. If you put 34, it's not going to be a big deal. Now, we are solving for the money. That's the question mark, but how many years? Well, they don't tell me how many years, so what I do with these 2 years, 2005 and 1980, is I go off to the side and subtract them to find how many years that was, and that's 25. So I'm finding 25 years. So do not make your line, okay? When you are repeatedly multiplying, that is not a linear function, okay? Instead, you write out your exponent function. Here's how to write an exponent function from a story problem. A times b to the x power caret x equals y. Now, a is your beginning amount for y, 55. It's a very easy equation to work from. The b is what you multiplied by all the time, the growth factor, 1.03. And then x power, and then y. Now, 25 will go in for x, and I will have 55 times 1.03 to the power of 25 equals y. So to solve for y, just plug that into the calculator. 55 times 1.03 to the power of 25. Just put that as 115. Okay, it's approximately $115. You can put that right there if you want. That's the answer. Okay, next one. You put $125 in a savings account that earns 2% interest each year. You make no deposits or withdrawals. How much will our investment be worth in 10 years? So years in dollars. Years is X, dollars is Y, so the money is a function of X. So per dollars per year. Well, there ain't a dollars per year, it's a percent, okay? So that means it's going to be an exponent function, okay? EXP. So you put plus 2% because interest adds onto it, but you got to do something else. You got to find your growth factor, okay? You take 100% plus 2%, and that's 102%, and you move the decimal twice to the left, 1.02. That's your growth factor. Plus 2% means 1.02. Okay. So years and money. So 0, 1, 2. So we started at $125. But with this growth factor, we do not add, okay, because a money plus a percent doesn't make any sense. It's always the operations to times by 1.02. So 125 times 1.02 is 127.5 times 1.02 again. Okay, 130.05. And that goes on and on and on. Now they do give me the years here. They give me 10, so I put a 10 there. I don't have to subtract like I did on this one. So to find what this is, I need to write the exponent function. When you repeatedly multiply instead of adding, okay, you write your exponent function, a times b to the x power equals y. So the a starts at 125, and what did I multiply? Well, I multiplied by 1.02 to the x power equals y, and x is 10. So x is replaced with 10. So 125 times 1.02 to the power of 10 equals y. Plug it in on a calculator, and you're going to have your answer. Just put $152. Okay, and you will get decimals. Okay, in the year 2004, a person purchased a car for $25,000. The value of the car decreased by 14% annually. Annually means per year. Okay, that's what that means. Calculate the car's value in the year 2012. So we got money in years. Years is X, money's Y, so per dollars per year. Well, there's not a dollars per year. Again, it's a percent per year. So this time it's going to be an exponential function, not a linear function, so you don't make the line. Okay, you're going to make a table, but you're not going to make the line. Okay, now decrease would be minus 14%. Okay, so I take 100% this time, and I minus 14%, and that's going to be 86%. Move the decimal once, twice, so you'd have 0. So this is a decay, okay? Whether it's growth or decay doesn't really matter. The setup's still the same. So that's called the decay factor. You put that up in your box. So 0, 1, 2. So I started at 25,000. And with the exponent factor, I multiply by 0.86. And that's going to decrease the value because I'm multiplying by less than 1. 21,500. $18,490. And now we're set to what we're trying to find. Now we're always solving for the money here today. Okay. Now to find the x, they don't really give you the years, they give you what the years are between. So you take 2012 minus 2004, and that's 8. So 8. Now remember, when we're timesing, do not make the line. Okay? In the exponent function, we go a times b to the x power equals y. So 25,000 is your a, times your b, which is a 0.86 that you keep multiplying by, caret x equals y. And then 8 goes in for x. Okay. Okay. 25,000 times 0.86 to the 8th power, 7,480. Okay. Approximately. Okay, next one. There are 128 teams at the start of a citywide 3-on-3 basketball tournament. Half the teams are eliminated each round. How many teams are left at the beginning of the fourth round? So teams and rounds. Rounds is the time unit, and that's Y. So per. Teams per round. Well, there's no specific teams per round. Instead, half the teams are eliminated each round, so it's going to be 50%. Now, eliminated would be subtracting, okay? So minus 50%. So that percent makes an exponent function. It will not be a linear. So with an exponent, I got to get my growth or decay factor. So 100% minus 50%. Well, that's 50%. So 0.50, okay? Put that right underneath it. Okay, so we got teams and rounds. Okay. 0, 1, 2. So at the start, there's 128 teams. Then you start multiplying, not adding. So you're going to times by 0.50. That's 64 times 0.50. That's 32. Okay. Now, rounds. How many we got? Now, you see fourth, but they haven't started the fourth round yet, so it'd just be 3. Okay. You could just multiply by 0.50 again. That would take you right to 3. A times b to the x power equals y. So you'd have 128 to start with. And then the growth, and then times 0.50 to the x equals y. And you put that 3 in for x, and go to your calculator. 16.